So the first thing we need to understand about data types is what is a data type. When we say data type, so there are two things. One is data, and the second part is type. So we'll say one is data. Second part is the type of data. So when we say data, data is any kind of information. For example, typically you see information like, let's say I'm a person and I have some information or data about me. Let's say my name. Let's say I have an age. Let's say some number. And let's say I have some more information. Let's say some addresses there and many more details are there. Cool. And there can be other kinds of data. For example, if you look over here, there are two kinds of different data that I'm storing, looking at the type of that thing. When I say type, I mean, this looks like like what we call in programming languages as string. String means basically a piece of text. And versus if you look at this, this is what we know as number, or typically in programming languages, this thing is called as an integer. So whenever we talk about data types, we are talking about the actual data. Data means the way or the thing that gets actually stored into the memory of the system when you are writing or when you're running a program, I should say. And the type is what kind of data you are storing. So it's basically kind of the data. Now, when I say the kind of data is somewhat ambiguous. Like you don't get to know what implications kind of data have in terms of programming or when we talk about programming languages. So let's see, or let's try to understand this thing with a few examples. Let's say I have two strings, let's say GAU, and then there is another string, say RAE. All right. So string means basically a collection of characters or something in Python which we enclose inside double quotes. These things are called as strings. Strings means a piece of text. And let's take another example. Let's say that this is a string. These are strings. And let's take another example where we have numbers, or what we call this thing in programming languages as integers. Let's take two integers here. Let's say we take a number 1 and we take a 2. We can take 0, -1, or any kind of number. That works fine in Python. So we are taking two numbers over here. One is 1 and one is 2. Now, these are the two data elements that we have. So when I type these two things, or if I run a program which uses these numbers or maybe these strings, then those things get stored inside the memory in the form of some data, and they consume some memory. So memory, when I say, is we are talking primarily about the RAM that is being consumed when your program is executing. And in RAM, your memory is organized in bits, bytes, your kilobytes, megabytes, gigabytes, etc. And so the same way, when I store this data, this is going to occupy some bytes of space inside your memory. Now coming from there, let's say I want to do certain operations on this data. So typically, if you say, if you want to do something like 1 + 2, and if I go and run this code, you see that this gives me an output of 3. If I go and do something like 1 - 2, if this thing works, then it's going to give me -1, and this thing works over here. Let's try the same thing with our strings also. Let's say GAU, and then I say plus RAE, and once I do this thing, it gives me a combined string or a combined piece of text, or it joins them. Like the first thing gets, the second thing gets joined with the first thing. And if I take this example again, but instead of using a plus, if I do a minus, this thing doesn't work. Why? Because this thing is not supported, or you don't know what to do when you don't know how to subtract two strings. All right. So when we talk about data types, there are two things. One is the data itself, which is going to occupy some kind of memory, and one is the type, or I should say, I typically prefer to call this as behavior of the data. Behavior in the sense, I can say if something is an integer or a number, I can add them, I can subtract them, probably I can multiply them as well. Something like this. 1 * 2 gives me, we go to the next cell. 1 * 2 gives me a 2. And but if I go and try to do these operations, all these operations which I've done with integers, it's possible that it might not work with strings. For example, plus is something which works, minus is something which won't work, we know, based on the behavior of Python. And if I try out star, that's also not going to work with strings. So when we talk about this data types, so we are worried about two things. One is the amount of space or memory that they are going to take inside your program. And the second thing is what is the behavior or what operations you can do on the data that you are going to store or you're going to create inside your program. Typically, when we are talking about data types or let's say in Python, the way we create store data inside Python is you create a variable, let's say s equal to, let's say my name. And this creates a variable by the name s, which contains or holds an object of type string, or it contains a data of type string. To verify that, we can say something like print type of s. Okay, so type is a built-in function in Python, which tells me what is the data type of the thing that I'm writing inside the brackets of type. So this should give me class str, and str is the name of the data type for strings in Python. And this thing is what I get when I try it out for a string. Similarly, we can try the same thing for an integer. So I'm going to take 10 and let's rename this variable to y for integer, and let's try the type. And Python has a type for integers which is called as int. So we have seen two data types right now, and when we talk about types, as I said, we are also talking about behaviors. So these both types that we see, they have different behaviors, and that has been verified over here. So this is the general idea. Now we have already said that when we talk of data types, we are talking about two things. One is the type of data, or one is the memory occupied by the data, and second thing is the behavior. So if someone is coming from a background of programming languages like C or C++ or Java kind of languages, if someone has such kind of background, probably they would remember that in those languages to create a variable. So in this example, I have created a variable of type integer, or I have created a variable I which contains an integer right now. If I have to do something similar in those programming languages, I would have to say something like int I equals to 10 or something like that with a semicolon property. All right. So what this does is when we go to these programming languages say that if I create an integer, there is a predefined amount of memory that gets allocated or reserved by the system for storing this 10. And for the modern systems with the 32-bit and 64-bit systems, the typical size of an integer on those machines is 4 bytes. So in such kind of programming languages, each data type has a notion of memory associated to it. But when we come to Python, we don't have such kind of notions associated with the data types. So when I say I equal to 10, I don't know how much memory it's going to take. It can be determined based on what kind of Python version and which specific version you are using, and how much that version uses for an integer, let's say for some basic integers or for the very initial integer values. Whereas in Python, you can also do something like I equal to 10 star star, let's say 100. And if I say print I, this is going to give me a pretty big value. And you can see that there are a lot of zeros inside this value. If I go and try to store the same value inside of programming languages like C, C++ kind of thing, it's not possible. Why? Because for when you restrict the data type in terms of memory or the size, the amount of or the range of values that you can store also gets restricted. So with a 4-byte with a integer of 4 bytes, it should be somewhere around 2000000, somewhere around this range probably, I think, or maybe somewhat higher. But you can see that even if I add few more zeros, let's say 2-3 more zeros, this value cannot fit into this kind of data type in such programming languages. Whereas in Python, the size of certain data types like integers, it's not fixed. It adjusts this thing dynamically, automatically based on how big a value you want to store. So maybe this 10 takes only 1 byte, maybe it takes 2 bytes, but this thing will take as many bytes as required to store all the data or to store all the information correctly. All right. So in case of Python, we are not very much focused about the size or the memory part of the data type. We are mainly focused about the behavior right now, and that's something that should be very clear when you're working with data types in Python. At least for the normal Python, we are not talking in terms of libraries which are specific to numerical computation like NumPy, etc., they have a notion of data type similar to C and C++ kind of languages. But in normal Python, we are mainly focused on the type of data or the behavior of it, not the memory part of it. So we have two things, memory and the date and the behavior part. So this is something very basic about data types in terms of how they behave. And one important function which I've already shown to you is the type function, which is used to determine what kind of data is being held by a certain variable. Another interesting feature of Python with regards to data types and variables is dynamic typing. What this means is, if I take an example, let's say s equal to my name, and then I say I equals to 10, and or not, let's say s equal to 10. So this is a perfectly valid thing to do in Python. So if I do something like this, and then I do type of s. So initially, if I run this code, first the interpreter would come to line number 2 and create a variable and make it point to a string, and which contains this data, which is my name. And then you go and you print the type of this thing. So right now, since s holds or points to a string, so the type that I see over here is str. Next, when it comes to line number 4, it reassigns this thing and it becomes an integer right now. So, and when you print the type of this s, you see that it says it's an integer over here. All right. So this is the behavior of data types in Python. And coming back, so, and this feature is called as dynamic typing. A couple of programming languages support this dynamic typing kind of feature, and Python is one of them. Whereas if you are aware of these programming languages, which are C, C++, Java kind of languages, they have a notion of a variable associated to a particular data type. And once it has been defined, since it is attached to memory and the memory size cannot change abruptly, or you cannot very easily change the memory size, and hence once you create a variable with a particular type, it sticks to that data type. You cannot reassign it to another data type. Whereas in Python, you have this feature of dynamic typing where you can assign data or elements of different data types to a particular one. And that's a bit of information about what a data type is. And another thing that I will show you soon is another function which is called as dir. I'll just show you an example of what this thing does. Let's say print dir of the variable s, which we had created in the previous cell. So the last value of s was integer, so this will be continued in this cell. And when I do this thing, you'll see that it prints certain things over here. So dir is a function which can be used to kind of inspect what kind of operations or what kind of things can be done or what are available in certain maybe a data type or certain variable or certain kind of object that's there in Python. And since s right now contains an integer, so it's basically telling me what kind of things can be done on an integer and things like that. We'll talk about it about it a bit more. So let's come to certain built-in data types available in Python. So typically each programming language has a notion of or a kind of categorization of data types into two categories. We can say one is like your primitive data types or the basic data types or the fundamental ones. And then there can be something like a non-primitive or something like a advanced. I don't know what the exact term should I be using, but I can say non-primitive data types or advanced data types, or let's say collections, some terms like that. So both of these data types are available in, or each programming language has a notion of these data types. So I'll call them as built-in data types. And when we come to advanced or collection kind of data types, these can be either built in or they can also be user defined. So if I wanted to create a third category, I can also add another category called as user defined data types. These are something which relates to topics which can be covered further, like classes and objects and all that stuff. So those fall under this category, the user-defined data types category. But otherwise, for now, we'll keep the discussion focused on primitive data types. What are the primitive data types available in Python? And this is a topic that needs like that cannot be covered in this session, and probably we'll have a separate session for that. So for this session, we'll focus on the primitive data types or the basic fundamental data types that are available in Python. And coming to this thing, we have already seen two of the data types that are available, and one of them is string data type and another is your int data type. So these are the two data types we have already seen. I'll mention the names of these data types. One for sure is integer, one is float. So both of these data types are used to denote numeric things in a programming language typically, and integers basically means positive or negative numbers like -10 or 0 or -1 or any number which doesn't contain a fraction, and these are kind of infinite in the count. Like we cannot determine how many total integers are there, so it can be any number of integers. There's no finite count. Floats are something which numbers which contain a decimal or which have a fractional part, we can say. For example, 0.0. So if you look at this thing, 0.0 is actually equivalent to 0, but when I say 0, the type is integer, versus when I say 0.0, the type is float. We'll see that with an example later. And again, these can be positive, negative, they can be something like this, they can be something like this, or they can be anything. So again, there's no bounded range or no fixed range for float data types, just like integers, but there are some things which contain a decimal point. Next thing which we have already seen is str, and these are the names which are actually the names of data types in Python. What I'm writing, I'm not typing string or integer, I'm saying int and float and str. So string is something which is a collection of characters, and it can be anything. It can be spaces, it can be numbers, even if you type numbers inside quotes. And strings, one thing to remember is like, if you put something in quotes, it becomes a string. So if I put a number inside quotes, it's not an integer. Or if I put something like this inside quotes, this is not a float. So my bad. So this is not a float. And these are all strings because they're inside quotes. Again, Python has a couple of options for creating strings. Like you can create strings with single quotes, you can create strings with triple quotes, and you can create strings with a triple quote composed of double quotes. These are some things which require much more discussion in depth, specifically when we come to strings. But these are the different ways you can create strings in Python. And strings are basically a collection of symbols or any kind of symbol. Even spaces are counted as symbols. The next type is the bool data type. Sorry, my bad. So bool data type is again one thing I forgot to tell you guys is like strings are also infinite, and you can create any length, any string of any length. The minimum length that you can have is a empty string or a string which doesn't contain anything. So this is also a string but of length 0. And when we come to booleans, so booleans have only two values. It can be either true or it can be either false. And these two values are predefined in Python, or you can find these two values, true and false, in the keyword list of Python. And Boolean is a special data type which can assume only two values. So it's a finite set of values, just two values are there. And it is used to denote whether something is right or wrong or true or false, and maybe right, correct or not correct. Next data type is a special data type again, which is none. None is something which denotes empty. So empty is not the value for none. It's none itself is the type, and none itself is the value for it. And there's nothing else apart from this for none, like no other values, and it's a fixed value. And it denotes empty, something like the void in other programming languages, or the null, or the nil. Sorry, my bad. It won't be void. It could be the null or nil or some other variation of null in any kind of programming language. So these are the few fundamental data types that are available in Python. Apart from these, Python also provides a data type to represent complex numbers, but that's not very frequently used, at least. So we'll focus on all these data types. Now let's follow with what I was telling you about these quoting of numbers and the difference between 0.0 and 0. So let's say type of 0, and then let's say print type of 0.0, and then let's make two examples for strings. Let's say this in quotes, and as I said, we can use any kind of quotes. So I'll use single quotes there and double quotes there. And if I run this code, you're going to see that we have the first thing as integer, second thing is float, then the next thing is string, then the last thing is also string. And let's make some examples for Boolean. Also print type of true, and it says bool. And similarly, we can say print type of false, would say a bool again. And let's try for none. N should be capital since Python is case sensitive. Hence the T of true, F of false, and N of none should be in capital since Python is a case sensitive programming language. It knows what's the difference between capital and small alphabet. So if you say print type of none with the small n, it's going to say name, sorry, I think it would say name error. Yeah, that's correct. It would say unknown value of none or something like that. So it says a name error, name none is not defined. Python doesn't know what none is. So if you define none, let's say none equal to none, and then you say print type of none. So none is over here, the none with a small n is a kind of variable which is containing the value of the actual none available in Python. And when I say type of none, it's going to tell the type of this thing, which is going to be none type again. So this is some basic notion of this thing. But another important part over here is like if you are using some variable name which is not defined, you're going to get this error, name error. So whenever you see this error, it means like you haven't defined it and you're using it. Another important thing to notice over here is that when you are using numbers, you can use them directly. Whereas if you are using some variables, for example, when I put none over here like this, versus let's make an example to make this more clear. Let's say print type of none, print type of this thing. So these are two different things. So whenever you type a name without quotes, Python treats it as a variable or a variable name, and it will try to find out what this variable actually contains or points to. For example, in this case, it was trying to find out what's none and it couldn't find it. Whereas in this case, after I defined it, it contains the none value and it gives me the type of it correctly. Versus when you type something in quotes, this is not treated as a variable. It's a string constant or a string literal. And these things which are constant values are called as literals in Python. For example, 0 is 0. You cannot convert 0 to 1. 0.0 is 0.0, and the string is the string. Whereas if I have a variable, let's say we have this none already, none equals to, let's say 1, and then I say none equals to 20, I can change the value which is being pointed by me. So if I do these kind of things, so I can do these kind of things with variables, and it's not possible with constant things or things which don't change. So these kind of things which are constant are called as termed as literals in Python, and the things which can change or the names that you define inside your program to point to certain data or to point to certain uh, information belonging to a particular data type, they are kind of variables. So this is the idea, basic idea about data types and how you can find out what is the type of the data contained or pointed to or referenced by certain variables. Now coming back to the first thing that I wrote, that there's two things. One is the memory and the second thing is type. We are not bothered about memory anyways. And we've explored certain data types in Python. Now it's time to understand thing about behavior. Say and let's talk about this. So I'll quickly show you one thing, which is I create a variable s1 equals to, let's say, abc, and s2 equal to pqr. I'm going to tell you something which is maybe it's kind of too early, but I want to give you a brief an idea about this thing, so that when you study more about object-oriented programming or building custom data types in Python, that it would be kind of a better, you'll get a better understanding of these things then. But I want you to have a basic idea about this thing. So when I see these two things, I have already shown you that I can do s1 plus s2 versus I cannot do something like this. So the first operation succeeds and it prints the value, and the second operation fails and it gives me an error which says type error, unsupported operand of type types for minus. It says you cannot do minus between a string object and a string object. So understanding these kind of error messages is also important, that you'll gradually understand if you're new to programming, but that's the overall idea. So if I go and I change these variables to integers, so I should be using I1, I2 or something sensible, but I'm going to keep it as it is, and this thing works. Now what we are going to do is we're going to do something which we have already done. We'll do dir of 1. We are going to inspect what kind of things are available inside these data types. Now, if you see these things, there are a lot of things which are starting with 2 underscores inside these data types. If you take notice of this thing, you have something add. So add means adding something. So we have done 2 operations over here. One is plus and one is minus. Minus is subtraction. So if I go and say sub, sorry, my bad. So if I say sub and I come over here, you're going to see that there is another thing by the name underscore underscore sub over here. Now, how this relates to your data types is these are these things starting and ending with 2 underscores present inside a data type, or later you'll understand about classes. These things are something special in Python, and they are called as kind of magic methods. And Python says that if some data type has this feature available, add, it means it can be added. If it has this feature available, it can be subtracted. Now, if I go and check the same thing for dir of any kind of string, it can be an empty string or string of any length. If you see over here, it has an add option, but if you look up for sub, it doesn't have a subtraction option. So it means you cannot do a subtraction for this thing. Cool. So when we are talking about data types, we have to focus on behaviors in Python. More specifically, what happens when you try to do certain operation on a data type, or how does the data type actually behaves. Another example of behavior apart from this addition and subtraction is a notion of length. So length means typically in terms of, we'll take first an example of string, say cd, and I can say print len of s. So len is a built-in function which says you can find out the length of a string. And if I do this thing, it's going to say 4 because this thing contains 4 characters. Versus if you come to an integer, and let's make an integer, let's say I equals to 1000, and if I say length of I, so integers don't have a notion of length. Integers don't have a length. Simply, if I do this thing, it's going to say an error because your integers don't have a length property. It's a type error. You don't have length kind of behavior or length feature to determine the length of an integer. It's not available, or that behavior is not satisfied by integers. Whereas if I take this thing and I convert it to a string, so the way to convert something to a string in Python is like this. So if you just say str and inside the bracket you put something, it's going to get converted to a string. I'll show you how this thing looks like. So if you print 1000 over here and 1000 as a string over here, actually they're going to look exactly the same. There's no difference while they get printed, but you can see now I can find the length of I because it's actually a string over here. It's not an integer. All right, so strings have a notion of length, or strings have a feature, or they have a behavior that you can determine the length of a string, whereas integers don't have that thing. So that's the general idea about data types, a very basic idea. Another thing I want to help you guys by, if you are ever stuck with this thing, is there is a built-in method available in Python that is going to help you in such kind of situations where you're often lost what is the actual data type of a thing, and you can use REPR for that. And if I put this thing over here, it's going to print it with a code. So REPR is a built-in method which is going to print a representation, or you can say kind of internal representation of something. And for integers, since integers are never quoted, it prints them directly. But if you print a string with REPR, it's going to put that in quote so that you can clearly see that it's a string, it's not an integer. And yeah, that's the basic idea about data types. I hope you understood what data types are, and what is the specific feature of Python with regards to data types, which is to focus on the behavior or how something interacts with the different operations or different operators that you can apply on a data type. and we are not very much focused about how much memory it takes. And we have discussed primarily the primitive data types over here. The advanced data types, or let's say the composite data types, is a thing that can be discussed in further sessions. Thank you guys. See you next time.